Hello everyone. So today we are going to discuss a topic called soil mechanics, or else we can call it as geotechnical engineering. So what is meant by soil mechanics or geotechnical engineering? What is the necessity of learning this subject? Why a civil engineer needs soil mechanics? See, we are having fluid mechanics, we are having solid mechanics. Then why soil mechanics? Because why we need soil mechanics is the soil does not fall completely in the category of solid, as well as it does not fall in the category of liquid. It cannot categorized as completely as a solid, it cannot categorized as completely as a fluid. Why? I will explain. See, how we generally apply load on soil. In general, we apply load on soil vertically. Generally, the load which is applied on a soil is in the vertical nature only. Always we apply vertical loads on the soil. Have you ever seen application of a horizontal load on a soil strata which is below the ground level? Okay, sometimes we may form embankments. We may use that to resist some kind of water retaining structures and all, but have you ever seen the horizontal loads application below the ground strata? Generally we use soil for taking the vertical loads. So why it is efficient in taking vertical load, why it is not efficient in taking horizontal load? Because soil behaves like a fluid, in horizontal plane, and it behaves like a solid. It behaves like a solid in vertical plane. So this is the reason why we cannot completely categorize the soil as a fluid, we cannot completely categorize soil as a solid, because it is having two different natures in two different planes. So that is why we need to analyze soil using hydromechanical study. So we need to study soil in terms of hydrological way, in terms of mechanical way. So that is why it is a study hydromechanical aspects of soil. So soil mechanics is nothing but study of hydromechanical aspects of soil is nothing but soil mechanics. Hydromechanical aspects of soil study is nothing but soil mechanics. So that is the definition of soil mechanics. Then what is meant by soil? Okay, we are saying that soil is behaving like that, soil is behaving like this. So first, what is soil? See, let us see soil. Soil is an unconsolidated earth or a material, an unconsolidated earth which contains soil particles, air and water in it. Soil particles, air and water in it. That means, why we are saying it is an unconsolidated material? Why we are saying this is an unconsolidated material? Because if it is a consolidated material, it is nothing but a rock. If it is a consolidated material, that means it is a compacted one. So compacted one, we define it as a rock. It is not soil. Soil will be in a form of a loose form, a divided form. If it is in undivided form, how can we say that is soil? So divided form means unconsolidated form is nothing but the divided form of a rock. So the unconsolidated form of the earth, and it contains majorly soil particles, and also it contains the voids in it. Those voids may be filled up with air or water. So this is the definition of soil, and that is the definition of soil mechanics. Okay. Now, so okay, definition part is okay. How it is originated, how the soil is getting originated, how the soil is coming, how it is getting generated, let us see. So origin of soil, origin of soil. Let us see the origin of soil. Origin of soil. So generally soil origination will comes out of a component of a geological cycle. If you understand the geological cycle, you will understand it is, so the origin of soil is a component of the geological cycle. Let us understand what is geological cycle. Geological cycle. See, the geological cycle is nothing but, see, when there are mountains like this, the mountains are the source of the generation of soil. So this is the source. From here, weathering takes place. Weathering takes place. What is weathering and all we will discuss in detail. So weathering takes place. So because of this weathering, the rock, some part of the rock will be converted into particles, divided particles, that is called soil. So that weathered particles are called soil, and then the soil is cannot stay here, it may stay here or it may get transported whenever some force is acted upon this soil particle. Now, so some part of the soil may settle down here, some part of the soil may be get transported. So this is transportation. This is transportation. Now after transportation, so at some location who is taking that soil, that a transporter will drop that at some location where it is having, the transporter has now ended up the energy, so it cannot carry that soil particle anymore. So at that location it will deposit that soil. So at some location or other, whatever the soil being transported will deposited. So this is deposition. So once the soil keeps on gets deposited at the same location, when the soil, it is continuously getting deposited at the same location, there the soil will form different layers of deposition, and the layers of the soil which are getting deposited upon times, upon many years, so they will get consolidated and they may become a rock. So upon continuous deposition, so of different layers like this, so all these layers will get consolidated upon with time. So all the layers of the soil which are deposited will get consolidated with time, and they will become again a rock. So again weathering, so rock weathering, so weathering, transportation. So again this is again a rock, so again this will be weathered. So this is nothing but upheaval. See, whatever the deposition becomes rock, upheaval, that is nothing but upheaval. So this upheaval again weathered, transported, again weathered, transported, deposited. So this is a cycle, it is a continuous cycle, and again it is the upheaval. So this is nothing but the geological cycle. So I have told you one part of the geological cycle. So this is the part of the soil phase. See, from here to here, weathering, transportation, deposition. So in this part of the phase, in this part the soil is existing, so rest of the part rock is existing. So this is the rocky phase and this is the soil phase, weathering, transportation, deposition. Now we are going to study about these three in detail. What is weathering, what is the transporting agents, and what is the deposition location, and how the soil types varies upon the location of the deposition. So now we will study different stages in the geological cycle in the soil phase. Let us see. Now, first is weathering. As I told you, majority of the soil is coming out of weathering. So whatever the soil we are seeing around us, it is all coming out of weathering. So majority of soil is getting generated out of physical weathering. Sorry, out of weathering, not physical weathering, out of weathering. And minor part of soil is getting generated out of decomposition of organic matter. So we call these soils as cumulose soils. So the soils generated out of chemical decomposition are called organic soils or cumulose soils. So whatever the soil, so major part of the soil is getting generated out of the weathering, and minor part of the soil is getting generated out of decomposition of the organic matter, and the soils generated out of the chemical decomposition of the organic matter are called organic soils or cumulose soils. In GATE examination or any other competitive examinations, they may ask for 1 mark. So what is the chemically decomposed type of the soil? So you need to choose the cumulose. Sometimes you might not find this option, organic soil. Generally this term is directly related because it is organic matter, then soils which are coming out of the organic matter will be the organic soils. This is the common thing anybody can know, but they won't give this term, they will ask you this term because cumulose soil you might not heard this name, that is why it is important for the exam. Okay, so organic soils are also called cumulose soils, but so these organic soils are not having any kind of engineering importance. The organic soils are not having any kind of engineering importance because they don't have the shear strength, they are very fibrous, they have very fine structure is there, so they will be having more void ratio. So all these are the unfavorable factors for us to see this in a structural point of view. So we cannot construct any kind of structures on this kind of soils. So that is why we don't focus on the properties of this soil because it is not having any kind of structural importance. Okay, so we will discuss more about the weathered soils. So let us see what is the weathering, what are the types of weathering. So what are the different soils which are getting generated out of this weathering. Let us see that. So weathering of soil. See, weathering is of two types. One is physical weathering, and next one is the chemical weathering. See, in physical weathering there are many factors which causes physical weathering. Major factors I am discussing. One is abrasion or attrition and attrition. Abrasion and attrition. And wedging action of ice wedging action of ice, change in the temperature, and growth of plant roots, in rocks. So these are the major physical weathering parameters, physical weathering forces which causes the soil. Let us understand one by one. Abrasion and attrition. See, you must know the difference between the abrasion and attrition. Sometimes in interviews, they may ask you what is the difference between abrasion and attrition. See, abrasion means wear and tear between two different compounds. See, when the wind or water is wearing and tearing continuously any rock, if the wind or water is wearing and tearing continuously a rock, then that is abrasion. When the rock is falling with some elevation, a rock is falling from a height and it is rolling down the slope, and this rock, while rolling down, it will cause a wear and tear with the surface from where it is rolling down. So that means rock and rock, between two same materials, the wear and tear is attrition. Between two different materials, if there is a wear and tear, then it is called abrasion. So major soil which we have seen in our universe, in our earth, is of abrasion, wear and tear soil only. There are many factors which causes the wear and tear. That is, it may be river water, it may be ocean water, it may be wind, it may be glacier, it may be gravity, whatever it may be. So all are causing wear and tear, because of which we are finding the soil. So that is a majority of the soil which we are seeing in our engineering point of view. All the soils are coming out of the action, physical action, that is abrasion, okay, which is nothing but the wear and tear. So wear and tear of rock. So the wear and tear of rock is causing the soil, okay. Now wedging action of ice. Wedging action of ice means whenever there is any faults or fissures present in the rock. So when a rock cannot be a complete solid structure, there may be some cracks in the rock also because of the faulty formations. Whenever the rock is forming, if there is any fault, if there is any material which is volatile, or if there is any weak material present in the formation, that weak material cannot sustain for larger periods. For example, see, this is a rock. For example, this is a rock. See, this is a rock. So this is nothing but the fissure. This is nothing but fissure or fault, okay, or fault. So fissure or fault. So this is the location where the water during rainy season, the water may come here and settle down in this gap. The water will enter the gap, and if there is a frozen conditions happens, if the frozen condition occurs there, then the water which is entered into this void space becomes ice. So we all know that when water is becoming ice, the volume of that water will increases. The volume of that water will increases. So now what happens? Because of the increase of the volume, the ice will push the rock. The ice will push the rock, makes it into two fragments. So likewise, so because of the wedging action of the ice, so wherever there is a void, in that void the water will enter and it will become, if the frozen temperature exists, then it will become ice, and while becoming ice, the volume of the water will increases and it will push the adjacent rock and makes it into small pieces, which is nothing but the soil. So that is nothing but the wedging action of ice. Change in temperature. See, change in temperature means rock is a combination of different minerals. Rock is a combination of different minerals. So different minerals will have different coefficient of thermal expansions. different minerals will have different coefficient of thermal expansions. For example, see, this is a rock. See, this is a rock. So this is a rock. This is made up of different minerals. This is mineral 1, mineral 2 and mineral 3. For example, there are different minerals. When the temperature is raised, okay, so this mineral 1 is having less coefficient of thermal expansion, then it will not expand. So the mineral 2 is having more thermal coefficient of expansion, so then it will expand like this. It will expand like this. This mineral 3 is having much more coefficient of thermal expansion, then it will expand much more. See now, because of the change in the temperature, so all the minerals, so because of the different thermal expansions, the rock is becoming a fragment. Okay, so because of different thermal expansion of different minerals, the rock is becoming soil. The rock is becoming soil. Okay, so likewise, change in temperature will cause the soil. Okay, so growth of plant roots in rocks. That means we all know, we have seen also, when root enters into the rock, then it will crack the rock and gets propagated in the rock. So this is also a natural reason. Everybody might have seen this. The growth of plant roots in rock also causes soil. So these are the physical factors. That means there is no change in the chemical composition of the rock. Whatever the properties of the parent rock will be the same to the whatever the new soil is formed. Okay, so physical weathering means the properties of soil, formed will be same as that of parent rock, and here in the physical weathering we will get the coarser grained soils. So coarse grained soils forms in the physical weathering, such as the coarse grained soils such as gravel, and sand. These kind of coarse grained soils will forms in the physical weathering. Okay, now in physical weathering, whatever the soil that is formed, what forces are predominant in the physical weathering, what forces are predominant in the chemical weathering, we will understand once we study the chemical forces which are acting on the soil. What are the chemical forces which are acting on the soil? Let us see. The chemical forces: oxidation, reduction, hydration, carbonation, hydrolysis. See, all are leaching, all are the chemical processes. Okay, so in every chemical process, there will be a reaction. See, here in oxidation, whatever the reaction that occurs in the presence of the oxygen, reduction in the absence of the oxygen. See, whenever if the soil is having any kind of material such as acids in it, or alkaline material in it, or calcium material in it, CO2, any kind of organic matter, if it is present, then the rock is susceptible for chemical weathering. That means there are active minerals in it. If the rock is having active minerals in it, then obviously those active minerals will not stay ideal. They will react with the whatever the compounds which are coming in contact with them, and they form say different precipitates out of the reactions. So that kind of, if you see iron is material, iron is a mineral. If iron is present in the water or in the rock, iron is present in the rock, then it forms iron oxide in the presence of oxygen. So it forms a precipitate of iron oxide. Likewise, it is one example. So whatever the mineral or a metallic cations are present, then it will react with the any oxygen or any other materials present in the atmosphere, and they forms a chemically decomposed soil. So here in a chemically decomposed soil, the properties of the parent rock may not match with the soil. Okay, if you see the hydration means if there is a soft rock, when a soft rock is submerged in the water. Okay, so when a soft rock is submerged in water, for example, if you see a soft rock, if you hold it in your hand, it looks like a rock. It looks like a rock. If you drop it in water, it will get disintegrated with excess moisture. It will get disintegrated with excess moisture, isn't it? It will become like a soft, if it is soft rock, it will become like a powder if you drop it in water. So that kind of rocks, the soft rocks generally become soil upon hydration. Carbonation means when there is CO2 inside the rock, or when there is calcium inside the rock, and the calcium inside the rock will get the CO2 inside the rock or from the external atmosphere. So this calcium will react with CO2 and it forms a calcium carbonate. So it forms a carbonic acid. So the calcium carbonate further converts into carbonic acid. So we all know that acid is having a eating nature. It whatever the surface it gets in contact, it will erode it. So by that way, so the carbonation is nothing but when the calcium is present in the rock and CO2 either present in the rock or it is obtaining from the external atmosphere, it forms calcium carbonate, and further it converts into carbonic acid, and this carbonic acid, whatever the rock is present, it erodes the rock and forms a soil. So that is carbonation. Hydrolysis means hydration is different, hydrolysis is different. Hydrolysis means when metallic ions are present in the water. When metallic ions are present in the water, then the metallic ions, for example, calcium ion is present or magnesium ion is present in water, then the magnesium ion or calcium ion is replaced by the H plus ion. So hydrolysis means first the water molecule will convert into H plus and OH minus. Okay, H plus, the hydrolysis part, water molecule will convert into H plus and OH minus, and this H plus will replace metallic ions. It will replace metallic ions such as Ca2 plus and Mg2 plus, like kind of thing, and it will form the precipitate. Okay, so this is nothing but hydrolysis. Though the hydrolysis means the water molecule will get diffused into H plus and OH minus ion and it replaces the metallic ions. Further it converts into soil. Leaching means when there is any minerals or salts are getting deposited on the surface of the rock. If a rock is getting chemically decomposed, so after chemical decomposition, the salts will be like a efflorescent. That means the salt will get deposited on the surface of the rock. Okay, the precipitates out of the reactions, chemical reactions will form on the surface of the rock. So whenever there is rain, whenever there is any water which is flowing through the rock, they will leach away all the salts which are formed. So that kind of phenomena is nothing but leaching. Okay, so oxidation reduction means nothing but, so the reactions, so oxidation means reactions taking place with the presence of oxygen presence of oxygen, and reduction means in the absence of the oxygen. Okay, hydration means when soft disintegrated rock is submerged in water, it gets diffused into soil. That is hydration. Carbonation means, so the effect of carbonic acid. So the carbonic acid, the CO2 becomes carbonic acid and erodes the rock. That is nothing but carbonation. See, these are the different kinds of chemical actions, chemical weathering. So in chemical weathering, whatever the soil has formed, so chemical weathering, the properties of a soil varies from parent rock, and very fine soils are formed, such as silt and clay. So generally silt and clay are formed out of chemical weathering. Gravels and sands, these are fine grained soils. We call them as fine grained soils. So the coarse grained soils are formed by physical weathering. The fine grained soils are formed by chemical weathering. Okay, so this is all about the weathering process. We have studied in a detailed way the weathering process. Now we are moving on to the forces of the weathering. What are the different forces that will be present in a physically weathered soil and in a chemically weathered soil? Let us see the forces. See, in a physically weathered soils are coarser. Generally we all know that physically weathered soils are coarser. So the body forces are predominant here. Okay, so physically weathered soils are coarser. So body forces are predominant here. Body forces are predominant. Body forces means, example, mass, weight, acceleration. So these are the body forces. Mass, weight, acceleration, these are the body forces. See, chemically weathered soils will have are finer. So surface forces are predominant. So what are the surface forces? That is electromagnetic force, cohesive force, so etc. These kind of surface tensions, these are the surface forces. So these are the chemically weathered soils, and this is the physically weathered soils. So now we have discussed basic type of soil. upon weathering. So we are going to discuss now what is the types of soil depending upon the transportation agent and depending upon the place of origin and place of deposition in the next class. Okay.